Okay, so let's take a little gander here. We have 3.5 quadratic functions, maximum and minimum. Quadratic function is ax squared plus bx plus c, and it's when a does not equal 0. Quadratic, here is your best way to see that it's a quadratic. You get the little 2 as the exponent there, signifying that it is a quadratic. So if you have an a out in front and that a is 0, that means all of this is 0. And if that's all 0, then it's no longer quadratic anymore because there's no longer an x squared. Example 1. Okay, so you have negative 1/2 x squared. And basically the easiest way to graph this stuff anymore, honestly, is to simply use a graphing calculator. Plug this in is really all you have to do. Literally go to y equals and put in parentheses a negative 1/2 in parentheses and then an x squared and press graph. When you go to graph, there'll be a table. To get to that table, you want to press second in graph and this table will appear. Now the table has an infinite number of points. I just took a section of the points so that we could plot just that section. But you could plot -3, you could plot -19, you could plot positive 27. So all the points are right there. That's my point. So I'm just going to plot these points. And we're going to try to see what's going down. Now, what I'm showing you here is this is for a regular x squared. And if you remember from moving graphs, what we talked about, moving graphs in the last section in 3.4, transitions as we called them, when you have a number out in front, basically what you're going to do is you're going to multiply the y by that to get your points. This is a quick way to graph if you didn't have a graphing calculator. Now, x squared, that's -2, 4, -1, 0, 0, 1, 1, 1, and 2, 4. Those are the common points you should just naturally know when you're talking about an x squared. Everything else moves those common points. So this -1/2 out in front means, hey, multiply the y number by -1/2. So 4 times -1/2, 1 times -1/2, 0 times -1/2, 1 times -1/2, and 4 times -1/2. When you do that, here's your new set of points. The x's all stayed the same, right? So the x's are all the same, but 4 times -1/2 is -2. 1 times -1/2 is -1/2. That's 0. That's -1/2, and that's -2. So those are the points you want to plot, and those are the points that if you plugged it in on your graphing calculator, you would see these points listed there. So plot these points. That's -2, -2. That is -1, -1/2. That's 0, 0. That's 1 and -1/2. That's 2, -2. Plot the points, and there's your graph. Now using that, this says, hey, now graph -1/2 x squared plus 4. So if you remember from the last section with transitions, this plus 4 here basically is stating that I'm going to take every single point that I have and I'm going to move it up 4. If this is a -4, then I'd move every single point down 4. This number all out here all by itself moves it up and down this axis, this y-axis. So I'm going to move all those points up 4. So took this point, moved it up 4. Take this point, move it up 4. Take this point, move it up 4. Take this point, move it up 4. And take this point, move it up 4. And there's your graph of -1/2 x squared plus 4. It's just kind of a review of your transitions. Come to me, jungle friends. So we have this graph, and we want to express this graph f of x in the form of a times the quantity of x minus h squared plus k. This is the formula we talked about in 3.4 when we were talking about transitions. If you can write an equation like this, then you can move it. Well, if you remember in trig when we were talking about this stuff before, in order to rewrite equations like this, you're going to have to write them using completing the squares. Okay, so we talked about completing the squares in the prerequisite section in Trig, and we talked about it in chapter 1. So if you want to look this up again, you can review it. We also talked about completing the squares again in chapter 2 when we were talking about writing equations of circles. That's exactly what we're doing here. So let's try to complete the squares here. And to do this, you have to remember that formula, which is b over 2 squared. So I'm going to take this section right here, and I'm moving the 50 out, because remember, you need a k, so that's why I move that 50 out here. I'm trying to rewrite this with a squared term. Alright, so I can't do completing the squares with a number out in front of the x squared. You just can't do it. So I'm going to take that number out. So in order to take that number out, I'm going to divide each thing by 3. So I divide the 3 by 3 and the 24 by 3, just so I can get rid of that number out in the front. But I pull that number out front now. So I make that 3 go on the outside. 3 divided by 3 is 1. 24 divided by 3 is 8. Now I can use the b over 2 squared formula for completing the squares. So 8 over 2 squared, which is 4 squared, 4 squared, which is 16. So I plug a 16 in there. However, you can't just add something randomly to an equation. Whatever you add to it to make the equation look the same, I have to take it away over here. That way I'm not really actually adding anything to the equation. If I add something to one side and I take something else away, adding a 16 and subtracting a 16 is really like saying I'm adding 0 to the equation, is what I'm doing. But I'm not adding or subtracting a 16. I'm actually adding or subtracting a 16, and keep in mind there's a 3 here on the outside. So really what I'm doing is I'm going to take this 3, multiply it, and 3 times 16 is 48. So really I'm adding 48 to this side. So if I'm adding 48 to this side, I have to subtract 48. If there wasn't a number out here, then I would have just subtracted 16. But because there's a number out here, the number I have there is a negative 48. So if you remember from completing the squares, this is the factor. So all this in here, if I was to factor this right here, it would be x plus 4 and x plus 4, because that's what my factor is. And those I can push together, 50 minus 48, and get 2. So I still have 3 on the outside. This becomes x plus 4 and x plus 4, which is really x plus 4 squared, because you get 2 of them if you remember from completing the squares. And 50 minus 48 is 2. And now it's in the form a parentheses x minus h squared plus k. Alright, and when we come back here, we'll try to finish up on the 3.5 notes on maximum and minimum. And I'll show you how you use that equation to find the max or min of your parabola.